Lesson 2.3, Solving Multi-Step Equations. In order to solve multi-step equations, again, the goal is to isolate the variable with coefficient 1 to one side of the equation using inverse operations by working backwards. The main thing you have to remember when you have more than one operation that you have to undo by using an inverse operation is the order in which you undo operations. So the first type of operation that you have to undo is the addition or subtraction. So first you look to undo addition or subtraction. Second, you look to undo any multiplication or division. Okay, number 1. Write down number 1, please. 11x plus 4 equals 29. So we notice that the variable in this equation is x. And there's two operations being performed on x. 11 is multiplying x, and 4 is being added to x. So this is a multi-step equation. I need to undo two operations. That's more than one step. So the first of the two operations that I will undo is the addition of 4, the plus 4. Remember that the inverse of addition is subtraction. So I'm going to subtract 4 from the left side of the equation. Whatever I do to one side, recall you have to do to the other. Remember that plus 4 minus 4 equals 0, cancels out. Okay, so let's go ahead and bring down the result of this one step. 11x equals 29 minus 4 is 25. So now we have the second operation that we have to undo, and 11 is multiplying x, so we need to divide 11x by 11, and whatever I do to one side, I'm also going to do to the other. So 11x divided by 11 leaves me with x, and 25 divided by 11. Don't worry about doing the long division and coming up with a decimal. You can either leave your answer as 25 over 11 as an improper fraction, or make it into a mixed number that would be 2 and 3 elevenths. So either one of those would be fine. Okay? All right, let's look at number 2 now. Copy it down. A plus 7 divided by 8 is equal to 5. Now, let's recall that whenever you have an expression, either above a division bar or below a division bar, it's as if that expression were within parentheses. So although we normally undo addition or subtraction first, that a plus 7 is seen as one term. It's seen as one, as grouped together through a parentheses. So the first thing in this case that we're going to undo is the division by 8. So how do we undo division by 8? We multiply by 8, and whatever we do to one side, we will do to the other. Notice here that 8 and 8 cancel each other, and of course we bring down the resulting equation. It's a plus 7 is equal to 40. Now we have the last step we have to take care of. The inverse operation of addition would be subtraction, so we'll subtract 7. Whatever we do to one side, we'll do to the other. Recall that plus 7 minus 7 cancel each other out, and here we have a equals 33. Okay. All right, numbers 3 and 4, I want you to work on your own. So pause the video now and then come back and check your answers. Okay, check your answers for number 3, a equals 5. And for number 4, n equals 31. Okay, number 5, moving right along. Let's do number 5 together. Copy it down, please. -3 equals 2 plus a over 11. So if I look at my variable a, I notice that there are 2 operations being done to it. 2 is being added to it, and a is being divided by 11. So the first thing I have to undo is the addition. So let's subtract 2 from both sides. So -3 minus 2 is -5. 2 minus 2 cancels out. And I'm going to bring down this positive a over 11. So now I notice that a is being divided by 11. To undo that, I need to multiply by 11 over 1, and whatever I do to one side, I do to the other. And so 11 times -5 is -55, and here a is alone. And that's my solution. Okay. All right, let's look at number 6 now. Number 6, 3 halves a minus 8 equals 11. So a is being multiplied by 3 halves, and 8 is being subtracted from that product. So first, I'm going to add 8 to both sides. Let's go ahead and do that. 3 halves a, -8 plus 8 is 0, is equal to 19. Okay, so 3 halves a. 3 halves is multiplying a. In order to undo multiplication, I have to divide. And when we're dealing with fractions, to divide, all I need to do is really multiply by the reciprocal. So this is going to be multiplied by 2/3. And whatever I do on one side, I'm going to do on the other. So 2/3 times 3 halves equals 1a, or plain a, equals 19 times 2 is 38 over 3. That answer is acceptable. And if you'd like, you can also go ahead and change it to a mixed number. 3 goes into 38 a total of 12 times, and 2/3. So either one of those would be fine. Okay. Let's move on to number 7. Remember, in the case, as is number 7, where you have an expression above or below a fraction bar, you must see that as one term. You see the grouping symbol there. So in this case, we won't take care of the addition or subtraction first. In this case, we first have to undo that division by 7 by multiplying both sides by 7. 7 times 8 is 56, and the 7's here cancel each other out. X minus 5. Now we're ready to undo the minus 5 by adding 5 to both sides. And so we have 61 equals X. Okay, I'm going to go ahead and pause the video. Go ahead and do number 8 on your own. Hit pause now. C equals 62. Check your work, please. Consecutive integers are integers in counting order. Consecutive means one after the other. So for example, consecutive integers are -2, -1, 0, 1, 2, 3. Those are listed in consecutive order. And they can be represented as follows. N, and after n comes n plus 1. Then after n plus 1 would come n plus 2. After n plus 2 would be n plus 3, n plus 4, n plus 5, and so forth. Because they are consecutive integers, they're one away from each other. Okay? Consecutive even integers can be represented as follows. -2, 0, 2, 4. Notice, please, that these are not one away from each other, but two away from each other, because when you're looking at even integers, you're skipping over each odd. Okay? So you would represent these as follows. N, and then n plus 2, and then n plus 4, n plus 6, n plus 8, and so forth. And the same is true for consecutive odd integers. Here's a list of consecutive odd integers. -1, 1, 3, 5, 7, 9, etc. These are also represented as follows. N, then n plus 2, then n plus 4, then n plus 6, etc. Notice that consecutive odd integers are two away from each other because they're skipping the evens that are in between. Okay, so just introducing what consecutive integers are helps us to then solve a problem like this. Number 5. Find 3 consecutive integers with the sum of 21. So if I have 3 consecutive integers, they're not even integers or odd integers, they're just consecutive integers, then I know that they are one after another. So they are one apart from each other. Let's call the first integer n. The second integer is n plus 1, and the third integer would be after that, which is n plus 2. It says, find these 3 consecutive integers that have a sum of 21. So, if these are the 3 integers we're talking about, we can write an equation that says this. The first one plus the second one plus the third one, when I add them together, the sum is 21. Now let's go ahead and add these. The first step is, of course, to simplify by combining like terms. So n plus n plus n is 3n. Now combine our constants. 1 plus 2 is 3 equals 21. And now we have a simple two-step equation to solve. So 3n plus 3 equals 21. The first thing I have to undo here is the addition. So we'll subtract 3 from both sides. I'm left with 3n is equal to 18. Divide both sides by 3 and n equals 6. Now what that means is if n equals 6, that's my first integer. N is 6. The next one is 7. And the next one is 8. Is it true that 6 plus 7 plus 8 equals 21? And yes, the answer is yes, that is true. So your answer here is 6, 7, and 8. Those are the 3 consecutive integers with a sum of 21. Okay, some independent practice today. Here I want you to do numbers 1, 7, 13, 16, 17, and 18. Okay, make sure that you write down any questions you have on this video on multi-step equations, consecutive integers, anything that you need clarification on, jot it down so you don't forget your questions for tomorrow. Okay, God bless you. Have a great night.